orbiting. Vibes. Chess. Sure, I'll just put it under chess for now. Okay. All right, and then we're going to go to Chrome tabs, edit it, actually add a game capture, perfect, that's all the setup I need. Let's go to blank board sheet for Roland and set up a chessboard, and let's specifically make this one the 3, 2, 4, 9 total by 10. So we're going to make a 9 by 10 board because that's what matters for this test. No, it's going to be 8 by 10 for this test for every single one of them. So 10 wide, 4, 5, 6, 7, 8. 8 deep. Set the border, and this is how chess programs, if I, can count, 5, 6, 7, 8, 9, 10. Let's actually type out 10. Do their boards for movement math, usually. And having everything set up this way, we'll be able to better explain what needs to go on for orbits. I'm hoping, because I don't know for sure, I'm hoping, because the one chess program that I know at all uses this AI setup, this setup for the positioning, that Fairy Stockfish uses something about the same or similar and just generates it at the start of the game. Don't worry, I know it's not all the same. We'll fix that in a bit. 51. Okay. First of all, align everything middle, align everything center, set the size of all the font to that. Verify. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 50, 60, 70. That's why. 71, 72. Forgot 77. Now it'll work out. Alright, now that we have all of that set up, usually the way you can look at a board state is you can define diagonally using these numbers, right? So we want a function where we can pick an x and a y to output all of the orbit values, or separate functions that will get us there. So what we're doing mathematically is trying to find the function that relates this point to this point, and then separately here. Here, I will first explain what orbiting is. So in orbit mechanic, right, if we set the center spot, because this is also going to be kind of how the knight works. So the knight moves here from here. So this x outputs all of these y values separately. So for example, you add 10 once to go up orthogonally, and you add 1 to go exactly to the right. You subtract 1 to go to the left, stopping at 41. You subtract 10 at a time to go down, and then you add 11 at a time to go diagonal, and you subtract 9 at a time to go diagonal this way, and you subtract 11 at a time to go diagonal this way, and add 9 at a time to go diagonal this way, right? Simple, easy. You set what all the values can be, only accepting certain outputs, because, for example, this board doesn't have a single number above 80. So, if you add 9 to 71, wouldn't you get 80? Hold on. No, it wouldn't be 71. Oh, does this just break on the first of the board sometimes? Okay, 4, add 9, 13, add 9, 22, add 9, 31, and then it would actually reset to 40 based on this board before keeping going, rather than going to 50. So you have to add 19 if you're going through the edge of the board. That's interesting. Anyways, what we are trying to do is actually to have a function with both x and y, where you have two different positions, and you're trying to determine every other position that would be the same relative. So let's say this y is going to be this lovely yellow square, the x is the orange, and our output is all 7 of these numbers. Do we have a function that works in all cases? Because this is a gross simplification. Maybe let's make this easier to see what the problem is. Let's set these to white, leave this one yellow, and we're also going to pick a green and a blue, and let's deliberately pick something that should be a little bit harder. So these cases, which is perfectly possible, is one piece having 3 pieces that can orbit on the board, and knowing the rules, I personally know that the blue flare can orbit around the star to positions 23, 27, and 63, as well as the yellow flare can orbit around the star to positions 57, 66, 64, 53, 33, 24, and 26. So I know both the input and the output, and I have to find what's in between. I think the easiest way to do that is if I can graph it. If we make an X and a Y and then actually graph it out, I wonder what this will look like. So let's start there. Let's add another visualization. Let's go to Sheets first and see if we can find a Microsoft Office program that will let me just make a graph like that. I think I should be able to do it in just in Google Docs. Yeah, insert chart. I'm looking for a data point graph, not a bar graph, not a column, not a line. Let's click line graph to start with. It's just an image. Why is it just an image of a line graph? I want to actually put data into this damn thing. The fuck? Yeah, this is just a picture. What the hell? Oh, there it is. Open source. Really is just the image. Oh, there it is. Okay. So now if I change this number 22, yeah, it will actually change the line graph. That's good. So we can yeah, we should be able to do this. There are, so we will make this. Oh, it's not going to understand. Yes, it is. Star position, and we need fuck. Alright, so we're just gonna know that this is star position 1 all the way down to star position 80. How do I do that? Yep. You're trying too hard to keep the graph small. Let's make this nice and big. I'm not going to need more than 8 rows, even though I'm going to use an absolute fuck ton of columns, so that should be good. Yeah, to here. And then make it larger, and I'll be able to see this just fine. Sweet. There's got to be a faster way to do this, but it's fine. Let's see if I can make chart style and change it. Setup. Chart type. Is there any others? Can I just get... scatter plot. That's what I actually wanted. No, let's make it a line. Let's make it lines. Because I have a plan that will make the line graph... I'll swap it between those two as I'm trying to look at it. Because once I have all of the data in, once I have different ways to look at it, I'll have better ways to think about this. Nice. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, all the way down, looking for mistakes. Great. 1, 2. Okay. Oh no. Doing this right would take an 80 by 80 graph. And that would only be the inputs. We have an X and Y, and we get multiple Z outputs. This is a 3D space graph. I see what my mistake is. Okay. Yeah, that's not going to work that way. So we're just going to have to open a new sheet. And make everything from scratch. Good news and bad news. Good news, now we could just use the numbers. The bad news, this is going to be hard as fuck to visualize. It's a fucking 3D space graph. Yeah, because you have an X and a Y, and you get multiple Z outputs in the scatter plot. because your X is position 1, the star position. Your Y is position 2, your flare position. And then you're just trying to see where everything orbits. Which, I guess it's fitting that something that can be expressed on the 2D plane turns in, but it's called orbiting. I guess it's fitting something called orbiting ends up being a 3D graph. Okay, let's just start with 1, 1. What are all the outputs? They can't exist in the same space, so we can immediately discount. There is when X and Y are equal, there is no Z output because X and Y cannot be equal. They cannot occupy the same space. Alright, that's step 1. So 1, 2. So let's remove this. First number is star position, flare position, output 11. Okay. One, 3. So we can do this for the entire 80. So 1, 3, again, will only have one output, and that will be 21. Oh, why did I put it in the 1, 1 spot instead of the 1, 2 spot? Alright, so this is 11, 21, 31, and so on. 41, 51, 61, 71, 81, 91. Well, it doesn't actually go to 81 or 91. Instead, once it hits 71, it's at 10. So this should be 2, 3, 4, 5, 6, 7, 8. Oh, and then there is no output for 9 or 10 because 9 would be off the board, 10 would be off the board. So we leave these two blank. I'm going to start marking those in a lovely red. Okay, so this might be a dead end. I might not get the data I want out of this, but it's fine. Yeah, because 9 and 10 are off the board, and 11 brings me to 2. 12 is another red. It's off the board. There's nothing. 13 gets me 22. Is there a way for me to set the top to be, instead of A to Z numbers? That's fine. That way I can know I'm on the right one. View. Format. Number. Oh, okay. So I can set the format of a spreadsheet to plain text to avoid some of the problems that we were running into before. Oh, you learn something new every day. Alright, fuck. Anyways, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Got 22 as the output. And 14 gets me 32. And then I'm assuming 42, 52, 62, 72, and then these next two will be red, right? Yeah. As I go this way, it goes this way. 9 and 10 become red, so this should be position 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Why is that one 20? 32, 2, 3, 4, 5, 6, 7, 8, 9. Oh. Oh, really? Does 8 go off the board too? Sooner? Hold on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No, the output for 8 should be 72. I need the top line to be numbers. God fucking damn it. Okay. Alright, this is apparently going to be a stream of me figuring out how to make Excel work. That's not going to be fun. Alright, I'm ending stream. This is not worth streaming.